Hey everyone, Kevin here with part 3 of my Modding Minecraft 1.8 with Forge series. In the previous video, we coded a universal template for creating Forge mods, and in this video, we're going to put that template to use. I'd like to revisit my first MCP mod where we added new blocks, items, and recipes. We could simply create standard blocks and items, then manually add them to the world generator and manually register them to the renderer. But instead, we're going to create a new custom item and block class extended from the vanilla item and block classes. Then we'll set up a series of custom constructors for those classes to automatically add them to the custom world ore generator that we're going to make. I always felt that the vanilla ore generator was lacking in one simple to implement feature. When adding ores to the world generator, the parameters are the minimum and maximum height to generate the ore vein, the size of the vein, and the amount of distribution. I would like to add two new parameters for generating ore: a generate in and generate near. Basically, you'll be able to define a list of blocks to replace with the ore. Normally the default is stone. And we'll be able to define a list of blocks to generate near to, and a maximum distance from those blocks. Sulfur, for example, should only be generated near and around natural lava blocks. Well, our ore generator will be identical to the vanilla ore generator, with the only difference that we'll be able to do all that with only one line of code to the client proxy and one line of code to the common proxy. So you should be starting off with the mod template we created in the previous video. So enough talking about it, let's get to it. Let's start off with the custom item class. Right-click on your mod package and create a new class. We'll call it custom item and click finish to create. As usual, we add the imports we'll need. And we extend this class from the item class. Then we create a constructor. Normally, in the main class, we would create our item object, then initialize it with all these values: its localized name, its creative tab, and its max stack size. Instead, we do that all here in the custom item constructor. Then we call the game registry, which is the Forge class that contains all the static methods for registering items, blocks, entities, and almost everything else into the Minecraft engine. We call the register item method in the Forge game registry class and pass this, which is the item itself, and the item's name. The constructor will be called in the common proxy because it needs to be initialized on both the server and the client side. However, the renderer registration is for the client only. So we create this function, register renderer, which we will be calling on the client proxy only. To register an item renderer, we need to make a call to the Minecraft base class and call the getMinecraft static function, which returns the Minecraft game instance. Then a getRenderItem call to the Minecraft instance, which returns the renderItem object. And finally, a getItemModelMesher call to the renderItem object gets us the model mesher, which is where we need to register our new item's model renderer. So we call the register function and pass this in the item parameter. The next parameter is a meta value. We pass 0 as the default value. The last parameter is a model location. An important note: when giving Forge a path to a resource, we do so with a string containing the mod ID and the resource name, separated by a colon. The second parameter of the resource location is an inventory string. Inventory is the string parameter for any object that can be picked up and placed in the player's inventory. And that's all for the custom item class. You can save and close. Now let's move on to the custom block class. Create a new class in your mod package and call it custom block. We add our imports. And we extend this class from the block class. Now the item class was pretty straightforward compared to the block class. Our block class will have several constructor overrides to accommodate the many different options we want to implement. The first one will be a simple standard block constructor. This constructor is for adding a block to the game that is not generated into the world. First, we'll start by adding a few important variables we'll need. Drop on harvest will contain the item that is dropped when the block is harvested. Drop amount max will contain the maximum number of items that can be dropped when the block is harvested. And max harvest exp, which we set to a default value of 2, is the amount of experience dropped when the block is harvested. We also need a couple of enumerators. One called harvest tool enum, which contains 3 elements: pickaxe, shovel, and axe. And a harvest level enum, which contains wood, stone, iron, diamond, and gold. This setHarvestLevel function is a modified version of an inherited function in the block class. It's used to set the tool required to harvest this block in the minimum level of that tool. I did this because I find it easier to use enumerators as parameters rather than integers and strings, which is what the vanilla setHarvestLevel function takes as parameters. This function takes 2 enumerators we just created as parameters and uses switches to convert them to the standard string and integer values that the vanilla block function takes. Then it calls the parent setHarvestLevel function at the end and passes those values. So far, so good. We have the enumerators we need and a helper function to make block creation a little easier. For now, I'm just going to minimize these by clicking the little minus icon next to them so they're not so intrusive. And we can finally get to the constructors. As I said before, this first constructor is a simple standard one for blocks that are not generated in the world. So the parameters for this constructor are the material, the block name, the block hardness, resistance, a harvest tool enumerator, a harvest level enumerator, the creation tab, and a drop amount max. First thing is to call the parent block constructor and pass the material. This is how you would normally create a block. Here we set all the block values you would normally need to set after the block initialization. We can set them all here in our constructor. By default, we use the static getItemFromBlock function and pass this as the parameter to set the dropOnHarvest variable. This sets the drop item of the block to the block itself. We'll create a function later to set this to anything else we want. Finally, we call the game registry, just as we did in the item class, and use the static register block function to register this block. The parameters are the block itself, which is this, and its name. Before we get to the other constructors, we need to create the custom ore generator classes that we'll be using. So for now, we'll simply add this renderer registry function, just as we did in the item class. Then we'll save this class and create the ore generation class. We'll come back to this later. So we create a new class in our package, and we call it Custom Block World Gen Mineable. We add the imports, and we extend this class from the World Generator class. Then we declare a few variables. Ore block is the block to be generated. The number of blocks is the amount of blocks to generate in a vein. The gen_in is an array of block types that the generated block can replace. Default is stone. Gen_near is another array of block types that the generated block must be near to. And gen_distance is the maximum distance from the gen_near that the new block can be generated. Now we create a constructor for this class. This constructor simply sets the values of all the variables we declared above. And we're going to add two constructor overrides. This first one is a simple override where we can just set the vein size. In turn, it calls the second one, setting the generate_in to the default stone. This second override takes a generate_in parameter and calls the main constructor above, passing null as the generate_near parameter and 1 as the generate_distance, which doesn't really matter since the generate_near is not going to be used. Now we need two helper functions. This first one is called isReplaceable. It takes three parameters: the world object, a block pose, and a block array. It will return whether the block at block pose matches one of the blocks in the gen_in array. This isNear function takes a block pose, a block array, a distance integer, in the world object, and it returns whether or not one of the blocks in the array is within the specified distance from block pose. Finally, we need one last function in this class, and it's a very long one. So instead of typing it all out, we're going to copy it from the native World Gen Mineable class. In the Package Explorer, expand the Reference Libraries folder. The first library in that folder is the Forge source library. Expand it. And scroll down to the Net Minecraft World Gen Features folder and expand that. Locate the World Gen Mineable class and open it. This is the native vanilla OR generator. Highlight the generate function and copy it. We'll be pasting this function into our custom class, and we'll modify it to fit our needs. Without going into too much detail about what all this obfuscated code does, basically for each chunk being generated, this function loops through all the blocks, and using an algorithm, it randomly selects stone blocks and changes them into the generated OR blocks based on the values that are given. At the bottom of this nested loop, select this if block and delete it. We'll replace this with our own conditional code. I'll just type this out so everyone can follow along. So what does this do? Well, at this point, block pose 1 will contain the position of a selected block to be vetted for changing to a generated OR block. We first check if this selected block's type is in our GenIn array. If so, we can move into this block of code. Then we check if the GenNear array is null. If so, it means we didn't define a list of blocks that must be near the generated OR block. So we simply change the selected block to the generated OR block using the setBlockState function. In the else condition, we have a list of blocks that must be near to the selected block pose. So we call our isNear function to loop through the GenNear array at a maximum distance of GenDistance. Our isNear function will check all the blocks around the selected block to the specified distance and compare them to the list of block types in the GenNear array. If a block from the GenNear array is found near the selected block within the specified distance, we can call the setBlockState function and change the selected block to our generated OR block. Now, an important thing to note is that the GenNear functionality of our custom OR generator should be used very sparingly. The amount of elements in the arrays and the higher the distance values will increase the number of loops exponentially, and will slow the loading of map chunks. Not to mention, crazy high values could result in a crash due to a stack overflow. So I'm only going to use this feature for my sulfur blocks, so that they are only generated within 1 to 2 blocks near lava blocks. And that's all for this class. You can save and close. One more small class to create before we can get back to finishing our block class. Create a new class in our package. We call it custom block gen. We add our imports, and this class is not extended, but it implements the iWorldGenerator class. And we declare a list of variables we need. GenBlock is our custom block to generate in the world. GenMin vein size and GenMax vein size are pretty self-explanatory. GenChance is the frequency of vein distribution. GenMin Y and GenMax Y are the minimum and maximum height to generate the block. GenIn and GenNear are the block type arrays that hold a list of blocks to generate in and near. GenDistance is the maximum distance from the GenNear blocks to generate the OR. And finally, 3 booleans that contain whether or not to generate this block in the overworld, the nether, and the end world. Then a constructor. The declaration line is very long, so I put it in the box here so you can get a good look at it. The parameters are just the values for all the variables we declared above, and the constructor simply assigns them to their respective variables. And another constructor override for the case that the GenNear feature is not being used. This one is also pasted in the box here. This constructor simply calls the first constructor and assigns null to the GenNear parameter. Now we create the 2 most important functions. This generateOr function creates a custom block world gen mineable object and passes this block's properties to it. This for loop calculates the frequency of distribution and populates 3 variables with random block positions, then calls our custom generator's generate function, passing that random block position. Finally, a generate function, which is a required function implemented by the iWorldGenerator class. To start, we make a call to the world provider and call the getDimensionID function, which returns which dimension we're currently generating, -1 for the nether, 0 for the overworld, and 1 for the end world. If the chunk we're currently generating is a nether chunk, and GenNether is true, we call the generateOr function we created above and pass all the required values. And the same thing for the overworld and the ender world. And we're all done with our generator classes. You can save and close. And reopen the custom block class we started earlier. Now we need to create a constructor that contains all the parameters to implement the custom world generator that we just created. Aside from the added parameters and an extra line of code, this constructor is basically the same as the first one we created. The parameters for this constructor are the material, name, hardness, resistance, harvest tool enumerator, harvest level enumerator, the creative tab, the drop amount max, and the new added parameters are the min vein size, max vein size, gen chance, min gen y, max gen y, a generate in block array, a generate near block array, generate distance, and finally 3 booleans called generate in overworld, generate in nether, and generate in ender. The added line at the end of the constructor right after the register block call is a call to the registry's register world generator static function. In the register world generator, we create a custom block gen and pass all the required values to it. When this constructor is used to initialize a block, the block will be registered, and then all the values defined in the parameters will be passed to this new custom world generator. The engine will automatically call our custom world generator's generate function when generating a map chunk. Now we need to add 2 more constructor overrides for variation in the way we create our blocks. This constructor is the same as the first one, except that it doesn't have the generate near parameter. However, it has a generate in parameter. It calls the first constructor and passes null as the generate near block array. Use this constructor when you create a block that is generated in a specific list of block types, but not near any specific block type. And one last constructor. This one has all the same parameters as the previous one, except that it also doesn't have a generate in parameter. It calls the previous one and passes only the default stone block as the generate in parameter. Use this constructor when you create a block that is only generated in stone blocks and doesn't generate near any specific block types. This is the default constructor, and it's the method used by all the vanilla ore blocks in the game. And we're almost done. Just need to add a few custom class methods. This set max harvest exp is obvious. These 2 set drop functions are used to change the default drop item when the block is harvested. There's an item and block override, so you can set any other block or item as its drop. This set drop max amount, of course, sets the maximum amount of items this block can drop when harvested. This get item dropped returns the item type that this block drops when harvested. This quantity dropped returns a random amount between 1 and drop amount max. This getExp drop returns the amount of experience to drop when the block is harvested. The value is between 1 and max harvest EXP. And we're all done. You can save and close this class. And open the main class. So how do we add new items and blocks? This is how easy it is with the mod we've just created. Let's create two new custom blocks called sulfur ore and potassium ore. All blocks and items must be declared as static objects. We declare them in the main class so we can easily access them from anywhere in our mod. And we declare two new custom items named sulfur and potassium. And that's all. We can save and close the main class. Now open the common proxy class. The blocks and items are created on both the server and the client, so we initialize them in the common proxy class. So let's initialize them in the init function. We initialize the blocks as new custom blocks. If you hover over new custom block, a small window pops up with all our constructors. The top one is for blocks that are not generated in the world, so skip that one. The one we want is the one that doesn't have the block arrays. And that's the bottom one here. These are the parameters for this constructor. And now we initialize the sulfur ore block. For this block, I want to be able to specify a list of blocks to generate in and a block to generate near. So we choose the constructor that has the two block arrays. In the generateIn parameter, we create a new block array and add stone and netherrack to it. Because we want this block to be generated in the nether, and for the generateNear block array, we add the lava block. And we set the generate distance to 1. So sulfur will be generated in stone and netherrack blocks at a maximum of 1 block away from lava. Finally, we want this block to generate in the overworld and nether, but not in the enderworld. And there's a couple of imports we need to add to this class. Now we initialize the items. The parameters for the custom item is the item name, the creative tab, and the max stack amount. And finally, we can call the setDrops function for each block and pass the items as the parameter, setting the sulfur and potassium items as the drops for their respective blocks. All done initializing our blocks and items. You can save and close the common proxy class. Now we need to register the renderers for the new blocks and items. We do that on the client proxy because only the client needs to render them. In the client proxy, in the init function, we call the register renderer functions we created in the item and blocks classes for each block and item. The parameter for the register renderer functions is the name of the model JSON file to use. And we're all done. You can save and close the client proxy class. Now this part is optional, but I'd like to show you how to print out to the console for testing and debugging purposes. Let's open up our custom block class, and in our constructor, we call the system.out.println function. This function allows us to print out to the console. And when our block is initialized, I want to print out initializing block in capital letters and the name of the block. And down in the register renderer function, here I want to print registering block renderer with the model name. Then save and close. Now open the custom item class. When the custom item initializes, I want to print initializing item in the name of the item. And again, in the register renderer function, I want to print out registering item renderer followed by the model name. And you can save that and close. Just like our original MCP mod, we're going to add a shapeless recipe to craft gunpowder out of potassium, sulfur, and coal. Open up your common proxy and add these new imports. And to add a custom recipe, we make a call to the Forge game registry's add shapeless recipe function. The parameters are the item stack to create and an object array of the items to use in your recipe. And then you can save and close. Okay, so we're on the final stretch. The only thing left to do is add our assets to the resource folder in their proper subfolders. Now, you could create all your assets folders and subfolders right here in the Package Explorer, but there's a much easier way to do it. So what we're going to do is create our assets folders and file structures here on the desktop and import it into the resource folder in our Package Explorer in Eclipse. So create a new folder on your desktop and call it Assets. Open it up and create another folder inside it. This folder needs to be called the same as your mod ID. In my case, it's Kev's Mod. And open it up. Inside this folder, we can start creating all the usual assets folders. The block states folder, the models folder, the textures folder, and the lang folder. Now open the models folder. In the models folder, we need to create a block folder and an item folder. Then go back and open the textures folder. In here, we need a blocks folder and an items folder. Now let's get all our asset files into these folders. Now I'm just going to use the same assets I originally created for the MCP version of this mod. I'll copy them all over to the new file system we just created. Block state JSON files are required for each block type and can be used to define different variations of the same block. However, these are just standard block state files with only one variant. These model JSON files only contain simple instructions to the game engine to use a standard block cube as the render model. However, you can create models made of many boxes of different dimensions and rotations for each block type. Let me know if you want me to create a tutorial on making custom models and model resource packs. There are programs you can use to export to Minecraft JSON files, but I wrote a small plugin for 3D Studio Max a while back to import and export Minecraft JSON models, and that's what I use for mine. In the Items Model folder, you need a model file for each item, but you also need a model file for the item version of the block. The item version of a block is what drops when you harvest a block with a silk touch. You might remember these textures from my original MCP block tutorial. The potassium ore block and the sulfur ore block. The potassium item and the sulfur item. And finally, the lang file. This file contains all the in-game names of the items and blocks. Now with Forge, we don't need to have this whole file. So we can clear the whole file except for the items and blocks in our mod. Now these are not the right names. Our potassium ore was named potassium_ore. And our sulfur ore was named sulfur_ore. There. Now we can copy these into our Forge resource folder. Open up your Forge folder. Under Source, SRC, Main, Resources. You can copy your Assets folder directly here. And then reload your project in Eclipse. And there it is. Now let's expand all the folders in our assets here. There's one thing we forgot to do. Remember that all paths in Forge need to have the mod ID and a colon to specify which package to look in. That includes all the paths in the JSON files as well. So I need to open each JSON file and add my mod ID and a colon at the beginning of each path. Alright, now let's hit the Run button and test out our mod. I'll expand the console window so we can see what's going on behind the scenes. And there's our output from the custom block and custom item classes. I'm going to make a creative map so I can fly around. As you can see, sulfur now only generates within one block of natural lava blocks. Now we can go check the nether. Remember, we set sulfur to generate in stone and netherrack blocks, and we set it to generate in the overworld and the nether. So the nether should be full of sulfur, and it is. Only within one block of lava. Now in survival mode, I made an iron pickaxe, and I'm collecting some potassium, sulfur, and coal to test the gunpowder recipe we added. Now that we have the 3 items, let's make some gunpowder. Okay, so we finished our mod. How do we compile it? Well, open up your Forge folder. In my first video, we made a recompiled bat file. Go ahead and run it. I sped this part up quite a bit. It actually takes a little longer than this. And you can find your compiled mod in the build lib folder. That's it right there. If you open it up in 7-zip, you can get a look at all the contents. Our custom classes, models, textures, everything is packed into this neat little jar file. Let's rename it to something more easily identifiable. I'll call mine Kev's Mod. And copy it to your Minecraft mod folder. If you load up Minecraft and check in the mod menu, you'll find your mod right there in the list. Now the description and information on the right side of the screen is populated by the mcmod.info file in your resource folder. It's all pretty self-explanatory, but if you have any questions about it, just leave it in the comments below. And that concludes this tutorial. Please remember to hit that like button and feel free to share and subscribe for more. See you soon.